Welcome all to this video lecture series on ESP32. I am Bibha Priya working at Entity Intelligent Devices and Smart Solutions. This lecture is about overview of this course. This course is divided into 7 modules. Module 1 is Introduction and System Setup. In this module, we will have Introduction to ESP32, ESP32 product family. ESP32 has a series of products: S series, C series, H series, and Classic 32. These are in the form of modules and they also release development boards. Then we will see comparison of the ESP32 with other common boards like Arduino Uno and Raspberry Pi. Then we will select a development board that our future lectures will be based on. We will select ESP32 DevKit C version 1, which has ESP32 Vroom 32E module, and this module has ESP32 B0WB chip. We'll see what this module, devboard, and chip means, where they are. We'll see the tear down pictures. Then we'll see the features of the selected ESP32 module. Then hardware and software requirements for this course will be discussed. We will then set up our system for the future lectures. We will be using Ubuntu 22.04 and we will run ESP-IDF on Visual Studio Code. Then we will end this module with a Hello World program to test the Visual Studio Code and its extension installed, ESP-IDF extension installed. Module 2 is about FreeRTOS and ESP32. We will be studying very closely the book Mastering the FreeRTOS Real-Time OS by Richard Barry and his team. We will occasionally also refer to FreeRTOS reference manual. Since ESP-IDF starts main task, that in turn calls all other tasks that we create in the program in our project. So we need to have a very good understanding of tasks, queues, semaphore, mupexes, etc. So we will see all these in details. This will be a hands-on course. We will experiment and learn with all the APIs that we have. Then we will see the ESP32 peripherals. Like all other microcontrollers, ESP32 provides all the peripherals that it should give, like GPIOs for reading push button inputs, controlling LEDs, LCDs, and pull-up pull-down concepts also we will see. So we will also control motors using PWM. We'll see ADC, TAC, RTC, watchdog timers, and interrupts. Then fourth module is on ESP32 communication peripherals. Microcontrollers on their own add very little to the IoT. The concept of IoT is complete with sensors attached to the microcontroller and connectivity of the microcontroller to the internet. So we will see how these sensors are connected to the microcontroller ESP32. We'll see UART, I2C, SPI, I2S, LCD, and many more touch sensors and many more. So in this module, we'll see the theory part, the working part of the UART. We'll see the timing diagrams of UART, I2C, SPI, and we'll then experiment on various sensors and we will see the data sheets also. Then come the internet part. In this part, we'll see how ESP32 connects to internet via Wi-Fi, how they work in station mode, when connected to access point, how they starts their access point, and we'll see provisioning, how to input the credentials, Wi-Fi credentials via provisioning. We'll run HTTP protocols on ESP32. We'll see MQTT. Then we'll see how to run RESTful servers on ESP32. Then we'll see how to consume RESTful APIs and web services. BLE. BLE is Bluetooth Low Energy specific series. H series is designed basically for low power operations. They have only BLE support. Then we will see the over-the-air firmware update. The firmware update on the go while the ESP32 is deployed. Then we will see the sixth module. In the sixth module, the advanced features like deep sleep, ULP. ULP is ultra low power processors that run during the deep sleep. They collect information from the sensors and they can store in the RTC memory, which the main processors can access periodically. They wake up, or the ULP can wake it up, and they access this RTC memory and work on it. Then we will see how ESP32 connects to AWS. Then we will see various third-party libraries like LVGN to control various types of screens and connect it to the ESP32. Then we will see the LittleFS, the machine learning using TinyML library. So TinyML, we will be using a separate module, that is ESP32 S3 module, that has a vector code for AI acceleration. We'll see how to run deep learning models in the ESP32 S3. For this, we will be using ESP32 Ruin S3 kit. Then we will end this lecture series with real-world applications from end-to-end projects. One specific project we will see on people counter, like in that the main processor will be in deep sleep mode and ULP will be collecting the people counter data, and periodically it will wake up and write the data in the RTC, and the main processor periodically it will wake up and collect the data and connect to the internet and send it to the server. So this will end this lecture series. Hope you are excited about the project and upcoming lectures. Thank you.